Hello, Algebra students. We are in section 9-3, day 1, and today we are going to be solving quadratic equations by graphing. So far you've been graphing quadratic equations, but we haven't been talking about their solutions or their roots. So that is how we're going to be solving them today. We're going to be graphing and then just adding one little extra kind of tidbit to it. So one way to solve a quadratic equation is for you to solve a quadratic equation that is set equal to 0 by relating it to its similar function where it would be y equals all of that stuff. So when we find those solutions, they're called lots of different things. They're called solutions. They are also called zeros, or the roots. So if it says find the solution, find the zeros, or find the roots, that all means the same thing, and it just means find the answer or find where it crosses the x-axis. So all of these are where it crosses the x-axis. All right, so we have lots of different options for how this could work out. For a quadratic equation, you've got one of three things that could happen. There might be no solution at all. There might be one solution or two solutions. So notice on this example, it does not cross the x-axis anywhere. So this would be a no solution. This one, on the other hand, the vertex is the only point touching the x-axis, so it only has one solution. And finally, it could have two solutions where the two sides of the parabola are touching it. Okay, so let's just identify some solutions in these graphs down here. Remember, the solutions or the roots or the zeros are where it crosses the x-axis. So this is crossing right here and right here. What are those coordinates? This one's coordinate is -2, 0. And then that one's coordinate is, -1, 0. My apologies. 1. That is a 1. And then this one is 2, 0. This one, on the other hand, does not ever cross the x-axis. It does cross the y-axis, but it does not cross the x. So this one is going to have no solution. And finally, right here, we have an example where the vertex is touching the x-axis, and it's touching it right here. That coordinate is 2, 0. So that's how we would just look at a graph and automatically know its solution. What happens if we don't have a graph? How can we find the roots then? Well, we can follow these steps, and that's what we're going to do for our next examples. For these next examples, we're going to talk about how to find the solutions of a quadratic equation when graphing. So step 1, you want it to be equal to 0. After that, you're going to graph the related function, and then you'll look at your graph to identify the zeros and all that stuff. So let's look at example 1. Step 1 is to make sure the equation is set to 0. This one is set to 0, so I'm going to be able to start graphing it over here. The first thing I do to start solving how to graph, I'm going to find the axis of symmetry. And that formula for the axis of symmetry is -b over 2a. So I'm going to plug into this equation -b. So I'm going to take the negative of -18 over 2 times the a value, which is 3. Well, this is +18 over 6, or 3. So I'm going to say that reduces to 3. And this is now my axis of symmetry. So the axis of symmetry is 3. I'll go ahead and graph that on our coordinate plane. So I'm going to go over to x equals 3 and put a vertical line through that. Now I need to figure out where the parabola is going to start. So we're going to take this x equals 3 and substitute it back into the equation. I'm going to try to calculate the vertex. So that's what we're doing next. We're going to find vertex. And the way we do that is by taking this x equals 3 and sticking it back into the equation. So this is going to be 3 times 3 squared minus 18 times 3 plus 24. When I simplify all of that, this becomes 3 squared 9 times 3, which is 27. So this is just becoming, I'll write it below just so you can see it. This is becoming 27 minus, and then 18 times 3, I don't know that off the top of my head, is 54. So minus 54 plus 24. When I get the actual answer, so I'm taking 27 minus 54 plus 24, I am getting negative 3. So here I'm getting y equals negative 3. This is my vertex. So this guy combined with that one, getting me the value 3 comma negative 3 is my actual vertex. So I'll just mark that for you guys. All right, so now we found our vertex. If you want, you can go ahead and plot that. You don't have to at this very moment, but I will. So I'm going to go over 3, down 3, and that is right here. That's our vertex. Now I'm going to find 2 more points. So if my vertex is at 3, negative 3, I'm going to try x equals 4 and x equals 5. So I'm going to try x equals 4. Try x equals 5, and let's see what we get. So that is getting me 3 times 4 squared minus 18 times 4 plus 24. And then the other one is 3 times 5 squared minus 18 times 5 plus 24. I'm just taking that x equals value and sticking it right back into my original problem. You're going to follow order of operations. So when I take 4 squared and multiply it by 3, I get 48. So then I'm going to take 48 minus 72 and then add 24. So 48 minus 72 plus 24. When I do all of that, I end up getting y equals 0. So the actual coordinate is 4 comma 0. When I put a 5 in for x, I'm getting 25 times 3, which is 75, minus 90, and then adding 24. So 75 minus 90 plus 24 is equal to 9. So y equals 9 here. The actual coordinate is 5 comma 9. So what we calculated here was 2 more coordinates, which were those 2 values. Alrighty, now we can plot these 3 coordinates on our graph and see what it looks like. So we already did the vertex, that was the 3, negative 3. Now we're gonna go over 4, up and down 0. And then the other one is over 5, up 9. Well, that's way past our graph up here, but I'll go ahead and put a dot just so we can see it. Now, this is only half of the parabola. This is only the right side. So I'm going to reflect it to get my left side. And it'll look something about like this, roughly. Let's connect these. Okay, so now I have the parabola graphed. What it's time to do now is to look at the graph and determine where are the roots or the solutions or the zeros. In other words, where does it cross the x-axis? It's crossing the x-axis in this location and this location. So those coordinates are 2 comma 0 and 4 comma 0. And there's our answer. Let's do that again. All of this part's old stuff, right? We've been graphing for a while. So the old stuff is the graphing. The new part is looking for the roots. Okay, so now for example B, This is not set equal to 0 yet, so we're going to want to do that. The way we're going to do that is by subtracting 5 from both sides, and then I'll have negative x squared plus 4x minus 5 is equal to 0. Now this is in a form that I can work with, and I'm going to start my process of graphing. My first step to graph is to find the axis of symmetry, so let's do that, which is going to be negative b over 2a. I'm going to carry over my negative sign from my formula, and then the b value is 4, so I'm going to substitute that in. The bottom of my fraction needs to have a 2, and then I'm going to substitute in a negative 1 for a. The value in front of the x squared is a negative 1, so I'm substituting that in. Now I have negative 4 over negative 2, which reduces to x equals 2. This is my axis of symmetry. If you want, you can go ahead and plot that on your coordinate plane. So x equals 2 is going to be a vertical line up and down like this. Now I want to find the vertex. So that's the next step to graphing. So I'm going to take that x equals 2 and substitute it into this equation right here, the new one that I said equal to 0. So I'm going to have the negative of 2 squared plus 4 times 2 minus 5. Well, 2 squared is 4, but then that's negative. So right now, this is negative 4 plus 4 times 2, which is 8, and then minus 5. When I add all those up, I am going to get y equals negative 1. So when I actually put it together with this x equals 2 and that y equals negative 1, the coordinate is going to be 2, negative 1. That is my vertex. I don't have enough information for a whole parabola yet, though, so we want to find 2 more points. But what 2 points should we use? We want to stay near the vertex, so I'm going to choose 3 and 4 for the x. So try x equals 3 and try x equals 4. When I substitute those values in, I'm getting the negative of 3 squared plus 4 times 3 minus 5, and then I'm getting the negative of 4 squared plus 4 times 4 minus 5. When I do my order of operations for this, I get negative 9 plus 12 minus 5. When I add all those up, I'm getting negative 2. So y equals negative 2. So the actual coordinate is 3, negative 2. Now let's do this one. So I have 4 squared first, which is 16, but then I'm taking the negative of it. So that's negative 16 plus 4 times 4, which is 16, and then minus 5. So that'll be negative 5. The actual coordinate will be 4, negative 5. So these are my 2 more points that I can graph so that we can see the parabola more clearly. Let's graph them. 2, negative 1 is the vertex, so over 2 down 1. Then I have over 3 down 2. And then I have over 4 down 5. Let's reflect those across the axis of symmetry. And when I connect them, notice the parabola is pointing downwards and it's below the x-axis. So when I look for my answers, there is nowhere where the actual parabola itself is crossing the x-axis. So this one is going to be an example where there are no solutions. Let's do just one more in this video, and then we will call it quits for the evening. We're going to do one more example. We're doing example C. It says x squared plus 9 equals 6x. The first thing we want to do is make sure it's set equal to 0. So I'm going to subtract 6x from both sides. And what I'm going to do, I'm going to automatically put it in the form that we need it to be in. So I'm going to say x squared minus 6x plus 9 is equal to 0. I wanted to put the x term in the middle because that's how we oftentimes see these written. And I didn't want it to be at the end so that we wouldn't get confused about where the b was and all that stuff. So now I can start in with my process of graphing. First is the axis of symmetry, which is negative b over 2a. In the b position is a negative 6, so I have the negative of negative 6. Then I have 2a in the bottom of my formula, so I know I'm going to have a 2, but what is in the a position? If you need to put your invisible 1 up there, then you can, but in front of the x squared is a 1. So now I have positive 6 over 2, or 3. So x is equal to 3 right here, and that is your axis of symmetry. We can go ahead and plot that on the coordinate plane if we so desire. Okay, now it's time to find our vertex. To find the vertex, we want to take that x equals 3 and stick it right back into that original equation. So that's 3 squared minus 6 times 3 plus 9. So this is 9 minus 18 plus 9, or 0. So the actual coordinate between the two of these would be 3, 0. There is our vertex. But we don't have quite enough information to actually graph the whole parabola, so let's go ahead and find 2 more points that would be on it. Remember, we want our points to be close to this, so I'm going to say x equals 4 and x equals 5, and let's see what we get for that. So try x equals 4, try x equals 5, and let's substitute them in. So I'm going to have 4 squared minus 6 times 4 plus 9. And then I'm going to have 5 squared minus 6 times 5 plus 9. This is 16 minus 24 plus 9. When I do all that in the calculator, 16 minus 24 plus 9, I am getting 1. So y equals 1 here. The actual coordinate or ordered pair is going to be 4, 1. Cool. When I plug 5 in, I'm getting 25 minus 30 plus 5, which gets me 4. So that coordinate is 5, 4. These are my 2 more points that I need in order to easily graph the parabola. So let's plot these 3 coordinates. The vertex is at 3, 0, so over 3, up and down none. Then I have another point at 4, 1, so over 4, up 1. And then another point over 5, up 4. But remember, this is only half of the parabola, so to get the whole parabola, reflect it over to the other side. And now I have that U shape that I was looking for. For my final step, I'm going to read this graph and determine, does it cross the x-axis anywhere? And if it does, at what coordinate? Notice on this one we only have one solution, and it's the vertex. So the answer is where the parabola crosses the x-axis, and this one is crossing at the vertex or at 3, 0. I will do some more examples with you guys in class, but for now, that's all we're going to do. I hope you have a great night.